Hi guys. So today what we're going to be doing is we are going to be sketching exponential function graphs by interpreting their formula. So I'm going to give you the general formula first, and then we'll go through what each part means, and then we'll do some examples, and then you'll have some practice ones to do on your own. Alrighty, so if you could update your table of contents, we are going to be sketching exponential functions. Again, I'm not sure how many pages that's going to take. It could take one, it could take two. So after we're done, I'll update the table of contents again. Okay? And again, as you're going through, whenever you need to pause the video, please do. So if you could turn to your page 62. And we're going to we're going to title that Sketching Exponential Function Graphs. Sketching. I'm just going to put exponential graphs, and that's on my page 62. Okay. So the first thing we really need to talk about is the general form for an exponential function. So as you know, f of x and y are interchangeable. So sometimes I'll be using f of x and sometimes I'll be using y. So the general formula for an exponential function is y equals a b to the x minus h plus k. So that is the general basic formula for an exponential graph. And if you think about it, your parent function is y equals b to the x. And remember, we talked about how that base can be anything except negative, right? It has to be greater than 0. It also can't be 1 because that's not an exponential function. That would just be a straight line, a horizontal line. Okay, so let's break this up into pieces. So A is our y-intercept before any shifting. Or transformations. Okay. So in a parent function, your a, so if we make that note, right, the parent function the a value is 1. So it has a y-intercept at 0, 1. Okay. My daughter is not happy right now. So I apologize that she's crying. Okay, so the a's value is that y-intercept before any transformations. I'm just going to pause this until she's done. Okay, sorry about that. Okay, so that a value, as we said, is the y-intercept before any shifting. The a is also going to tell you if your function is reflected over the x-axis if A is less than 0. So if A is negative, then your graph is going to be reflected over the x, just like when we did absolute value functions. It's also going to tell you if your graph is stretched. And again, that is if A is greater than 1 or compressed. If A is between 0 and 1. Okay, so A tells you all of that. A is going to tell you where that y-intercept would be before any shifting or transformations. It's going to tell you if your graph is reflected over the x-axis, if it's negative, and it's going to tell you if your graph is stretched, so it goes up faster, if A is greater than 1, or compressed, meaning goes up slower, if A is between 0 and 1. Okay, so that A value tells you a lot. So our B value. The B value is our base. It's also referred to as a multiplier. And if B is greater than 1, we have what's called exponential growth. So your graph will look like that. And if B is between 0 and 1, we have exponential decay, which means it goes down this way. Okay, so that's really the only thing that B is going to tell you. It's not, so if you have like 0.25 as your base, or 1/4, if your base is 1/4, it really just tells you that your graph is going to be going this way. It doesn't mean anything else for you at this point. And if, like we've been doing our bases too, so all of our graphs looked like this. So the base doesn't really tell you much, just which direction your graph is going to be going. Okay, so growth, it's going to be going upwards this way, or decay, it's going to be going this way. So growth, your y values will be increasing as x increases, and decay, your y values will decrease as x increases. Okay, so that's what your B is going to tell you. Now, your H value, see how it's minus H, just like in absolute value? That's the same thing. So your H values are going to tell you your horizontal shifting. And what we mean by shifting, what I tell my students to focus on when we talk about shifting, the whole graph is moving, but when we're dealing with sketching the graph, we're really looking at that y-intercept. So that's going to be the easiest point on an exponential function. Sorry. That's going to be the easiest point for you to focus on because there is no vertex. So the easiest point for you to focus on when you're sketching an exponential function is, wow, is that y-intercept. So that's what I mean. Like the whole graph is shifting left or right, but when we're sketching it, we're going to focus in on the y-intercept. So if you want to make that note, so focus on the y-intercept shifting, because that will help you sketch that graph a little bit easier. So just like with absolute value, if you have if you have x minus h,
No.
come here, you want to sit on my lap? You're going to help mommy teach? Okay. Let's help mommy teach about exponential functions.
I have pens.
No, you can't use my pens. Here. So if we have x minus h, that is a shift to the right. And if we have x, Paisley, if we have x plus h, that's a shift to the left. Okay, and again, we'll be focusing on that y-intercept that will be shifting. Okay. Okay. So we've talked about A, we've talked about B, we've talked about H. So now let's focus in on K. Paisley, can you sit over on this side? Thank you. Here. So our K value, this is our vertical shift. Okay, so if it's plus K, obviously we're going up. If it's minus K, we're going down. And this also tells you your horizontal asymptote. And it will help you identify your range. Oops, sorry. Okay, so the K is the vertical shift, plus is up, minus is down. It tells you what your horizontal asymptote is, and it helps you to identify the range of the function. Okay, I know that's a lot. So I'm going to do some examples. I'm going to break it down into steps for you to make it a little bit, well, to make it as easy as I can. Okay, so here comes my daughter again. So I'm going to pause.
Mommy.
Where I'm going to pause the video. Okay, sorry guys. All right, so let's sketch the graph for f of x, f of x equals 1/2 to the x plus 1. Okay, so we're not going to make a table yet, but that is part of it. So step 1 is going to be, so step 1, we're going to identify the A value. So before any shifting, right, the A value is 1, right? So that's like 1 times 1/2 to the x. So our A value is 1 before shifting. So that's going to tell us that it is not reflected. So it's going to it's going to be above the x-axis. And it's neither stretched nor compressed. So it's just going to be like the parent function, f of x is equal to 1/2 x. Okay? So our A value is 1. So let's look at the B value. So our B value right here is 1/2. So it's less than 1, so that means our graph is going to look like this. Okay? That's what the 1/2 means. So my b value of 1/2 tells me I have exponential decay. Step 3, do I have any horizontal shifting here? No, I don't have any. So identify your h value. Our h value is 0, so there's no shifting on the x-axis. Okay. Step 4 is to identify your k value. All right, so my k value plus 1 shows me that this function is shifted up 1 unit, right, from its parent function. So it shifts up 1 unit. So now our asymptote is at y equals 1. That also means that my a value that was 1 before shifting also moves up 1 unit. So my new a value, or my new y-intercept, is at 2. Okay, because the a value here is 1. That tells you the y-intercept before any shifting occurs. Okay? So now my asymptote, or my vertical shift, this whole graph moved up 1 unit. So my y-intercept was at 1, now it's at 2, because the whole graph moved up 1. Okay. So now what we can do, step 5, we can draw the asymptote and y-intercept after shifting. Okay, so I'm going to go on the side here, and I'm going to make a coordinate plane. I know I'm not going to be going into the bottom 2 quadrants, right? So I can draw my axis like this. So here's my x, here's my y. Here's 1, 2, 3, 4, 5. And then 1, 2, 3, 1, 2, 3. So I'm going to draw in my asymptote, which is 1, because that's my k value. And remember, my k value tells me my horizontal asymptote. So I'm going to draw in my horizontal asymptote. And then my new y-intercept, because remember, before I shifted this graph up 1, my y-intercept was here, but it shifted up 1. So my y-intercept is now here. Okay? So now, since we're sketching, we can pick a value to the left and the right of this point here. Okay? And we're going to make a table. So that is step 6. So step 6. Oh, you can't see that color, huh? Let's use this one. So step 6. Choose a point to the left and right of the y-intercept. and make a table. I should probably hide that notification there. There we go. All right, so I know this looks really, really, really scrunched up. Okay, so we're gonna choose a point to the left and the right. So at -1, and I'm going to, I don't want to confuse you guys. So on here, I'm just going to do this on here. You don't need to write it. We'll make tables for the others, but I don't want to like have just a table on the other page and it not make sense. So I'm going to make a table X and Y. So I have 1 point over, I'm going to choose the easiest points, -1, and 1 point to the right, +1. And then I'm going to substitute those in, right? So I have f of x is equal to 1/2 to the x plus 1. So if x is -1, right, I have to take the reciprocal of 1/2 and raise it to the first power, which would be 2 and then plus 1. So my y value is 3 when x is -1. Okay? So at -1, I'm going to go up to 3. So -1, 1, 2, 3 is right here. Okay? Which makes sense because I know I want a decay graph. So I want a graph going this way. So now I want to figure out what my y value is when x is 1. So if I have f of x is equal to 1/2 to the first plus 1, 1/2 to the first is 0.5, and then 0.5 plus 1 is 1.5. So now I can graph 1, 1.5. And since I know my basic exponential function, right, I know that it's going to come down, it's going to come close to that horizontal asymptote, but it's not going to touch it. And it's going to continue to go in that upward direction in the other way, right? So that looks messy, sorry. So there is a sketch of the graph. So I know that sounded like a lot, right? A lot of steps, but the more we practice, the easier it's going to be.